Hello, we're Dream. I'm Danny.
I'm Ricky.
I'm Ian. I'm here.
I'm Matt.
And this is our robot. We originally started off making a sort of catapult, but after a while we found that it was a really hard to program and it was just mechanically faulty. So we redesigned it to 2 or 3 more times before we got to our end result, which was a very compact robot that just runs around and screams at things apparently.
We started off doing the catapult because we thought that was the first project. Obviously we were wrong, so then we started trying to figure out, okay, how can we program a catapult to go around a black line, and didn't quite work out. So then we started doing some redesigns. I took it home over one of the weekends, and we did roughly a 6-to-1 ratio on the gears there, and the thing was like a track car, and it just took off. However, that also led to problems with programming because it's very hard for it to get an accurate reading with the light sensor while it's just flying down. And then we also did a rack and pinion system, which I thought was probably the coolest feature. The motor up top spins up and down, and then it would turn the rack and pinion system either left or right. Programming that to be functional, tracing the black line, I couldn't figure it out. So then we redesigned it one last time into this guy here. You guys want to take over on that?
Yeah. So this is our final design, and as you can see, we have a few. Well, we have all the sensors on there, obviously. It's kind of hard to see here, but this is a back view of the robot. This picture here, and on the front we have the ultrasonic sensor to detect the distance from the wall that we're placing on the track. As well as right here, it's hard to see, but that is our sound sensor, which when we clap, it activates the robot to engage. And over here we have our third motor right here, which activates with this arm to push the button up there, which, I mean, you'll see what that does. So.
And then the general underside build of this robot, it's super compact. It's just these motors attached to the main block. At a very low profile. It's really wide, but it's super low. Motors are ungeared. We decided that, again, gearing was too difficult to get accurate. This back wheel here swivels and rotates entirely, so it'll follow the robot in whatever direction that it's turned. And it's connected in the back, and all the wires there are very jumbled up and messed up, but that is our essential robot.
And the programming details that we did. So, like we had mentioned, it starts off with the sound. When you clap, it'll start this first loop here. When it starts the loop, it's going to get a value from the light sensor, and it takes that value and divides it by 20, so you get 5 different possibilities, 5 different outcomes for a reaction. So starting from left, you would have motor B turn fast, motor C turn much slower, and then in the middle, they're both the same exact power. And on the right side, it's the opposite of the left. That way, regardless of how it's operating, it's going to be a nice smooth transition. And then this loop finally ends once it detects an object close enough to it. And when that loop ends, it stops both motors from driving and then begins the second loop. The second loop, it's going to start motor A, which is the third motor on top there holding the lever, and then it's going to wait until the button is pushed. So once that button gets pushed, it stops motor A entirely and enters this loop here. When the button is pushed, it plays a sound, moves A motor backwards so it lowers the lever again, and then repeats the loop a total of 5 times. Once it's done with that, it exits the loop, turns on both of the drive motors again, waits 1 second, plays a sound, and then moves forward. And this is just kind of a collage of a little bit of everything. We've got our logo down at the bottom there. Pretty much everybody on the team except for me because I was taking all the pictures. And that is one of our other redesigns. Actually, I think Ricky knows most about that one.
Which one? Oh yeah, that was a bad design. I'll just say that. It was too long. We had the sensor at the front of it and the wheels in the back. So when it turned, the sensor would go out way off the line and then have to find the line again. So by the time you went around the corner, you were already going around another corner before it found the line again. It was very boring. I will admit that.
Any questions?
Okay, let's see. Yep.
Here, I'll let you do the homework.
Just to get an accurate light reading.
Now watch it not work.
Now we've tested it 10 times.
Okay. Yep, thank you.